Testing. Testing. Testing 1, 2. Hello.
Hello, can you hear me?
Yes.
Oh, interesting.
Actually, so yeah, let me see if this is working. So in theory, I just started a live stream on YouTube,
Oh,
and I think your audio should be coming through on the live stream, just to let you know that that's happening right here.
oh, okay.
But yeah, it looks like the levels are good. Sweet. I think it's all working. So yeah, welcome. Can you see? And I'm still getting set up. Can you see my screen?
Not in Discord.
Here we go. Okay, now my screen is should be in Discord too.
Yep.
So hopefully it's a smooth experience. Okay, so how are you doing? How are things? What are you hoping
Yeah,
to get out of today?
yeah. Yeah, things are good. I've been in BizHub a little bit,
Sweet.
building things.
Nice, nice. Yeah, I've been working on a new prototype of VizHub, like rewriting the whole thing, like the UI and everything. But for now, it's working as it is, and I love the AI feature. That's what I want to focus on making better and better.
Yeah, that's exciting.
Okay, so I am ready now to launch into this. So, yeah, welcome, and maybe more people will join. Welcome to episode 3 of this new live stream where I'll be creating these various code examples. I also wanted to share that I have aggregated the code examples to date from this live stream series into a new repo called CV Code Examples. And this just downloads all the code out of VizHub. Um, and I think the latest that we actually did, what was it, the scatter plot, or I think it was the bar chart. So the line chart was what we worked on last time. And I think for today's session, I wanted to make a bar chart here. I'm getting some background noise from someone in the Discord. Oh, welcome, a new person. So just for your information, I'm live streaming on YouTube, so anything you say is going to end up in the stream. But yeah, welcome to the stream. How you doing?
Might be AFK there.
I will mute them. There was just some background noise. So anyway, I think everything is still working. Yes. So, I was thinking about what to do next in this series, and my original idea was we do the scatter lead up to the scatter plot as like the stem cell that we can then fork and modify to differentiate it into different visualization types. And we did it for the line chart, and I think today I want to do the bar chart. Should be quick, just for completeness sake, and then we could maybe branch out into something else or collaborate live. That's one of the things I want to do with this live stream, inviting people in so folks can stop me and ask questions along the way and also contribute. And maybe we could do some like collaborative prototyping of some data set or something. But I think I'll start with this bar chart idea. Any questions before I dig into this?
Not yet. Not from here.
Nice. So I got my coffee ready. Thanks for joining. This is really fun. It's the first time somebody came, so I'm excited. So feel free to stop me and ask questions along the way.
I've been here for all three of them, though.
Oh yeah, sweet. But just sort of listening. Nice, nice. Cool. Well, this is the first time someone's talking, so this is going to be fun.
Hooray.
Hooray. Okay, so last time my whole system crashed and I got stuck on the bar chart because I didn't have the data prepared. I was looking at these references which pull in the entire UN data and then do a bunch of like data processing on it. Which actually is not that bad. But that's what I got stuck on. But for the purposes of this, I just wanted to do something super simple. So I dug up this old data viz that I did, which has a very simple data set. I swear I just had it open. This is the one. Let me close out these others. And then I'll tee up a starting point. So the idea is we want to make a bar chart. I will start by forking this, pulling in the new data for the bar chart, and then using the AI code editing to make it happen. And for what it's worth, I'm drawing this data from this very old bar chart I did back in 2018. This is like the first, could be the first version of this course that I did. I'm curious to see what the code looked like back then. Just as a quick aside, we're pulling in the D3 global. We got this bundle.js confusion. This is the old runtime version in VizHub. But anyway, index.js is there. It's pure D3. We have a render function. But it's remarkably similar to the code we're writing today. The only difference being mainly the React scaffolding around it. So I'll start by forking this scatter plot. And I'll call it CV for the Constructing Visualizations series bar chart. Forked, and then I'll go open editor, files, data.csv, select all, delete, and then copy the data from the other one and paste it. And then what remains is to change this scatterplot code so that it is no longer a scatterplot, but is instead a bar chart of the updated data in data.csv. So that was voice dictated, fed into the AI, and it worked. Hooray! See, this is this is it right here. I feel like we're living in the future. So let's review what it did. I think I'll just look at the individual files instead of trying to parse out that diff. So viz.js, well, let's start at app.js. The data parsing logic has been updated. Now we have country and population. We're also giving an ID. Oh, the clickability is still there. Sweet. That's what the ID is for. And then it just changed the config options. See, this is the value of putting all the tweakables in one spot, because you just have to change it there. And then there's bar opacity. I don't think that makes sense. So let me see. Remove the idea of, and then I'll type that bar opacity. And I don't like, so sometimes these AIs think that all bars should be like this steel blue, but you know, I want to say and don't, or sorry, make the bars black. Just with the default fill. Yeah, so just a simple, it just simplifies things. And it's also a pretty slick interaction too. So where were we? Viz.js, so now there's no, sorry, we were in app.jsx analyzing this, and now there's no option for the opacity, which I think is correct. Okay, and then how did viz.js change? Not really at all, but the scale creation will have changed, and now we have render bars instead of, I think it was render circles. Render axes should be untouched. It's the same, because that code would work for various types of scales, which is the beauty of D3 axes. Let's check out how the scales are different for a bar chart as opposed to a scatter plot. Instead of scale linear, we have scale band for X. And then the domain, instead of being the extent, it is all of the values for X value. So this is all the country names. So it's an array of strings, country names. Those are the domain values. So we pass the country name in, and then the scale will give us the X position of the bar, and then the width of the bar too. We'll see that later. And the width of the bar depends on this thing called padding. See, if we adjust the padding, this is the spacing between the bars. And there's also inner padding and outer padding that you can tweak as you like. But it's really an aesthetic thing. It comes down to like design, brand guidelines kind of thing, in my opinion. Although it really depends on the data too. Often I like to create something with the data and then just tweak it to see what feels right. But actually, you know, this I don't want to rabbit hole too hard on it, but this should be configurable. So let me just do that refactoring real quick. Refactor early and often. Add a new option to the viz function called bar padding and pass that into create scales instead of the hard-coded constant 0.2. Sweet. And it defaults to 0.2. That's what this syntax is here. So it's inside the destructuring when we use equal to. That means if we don't specify it from the outside, this is the default that it gets. But I don't think it's relying on that because it's passing in bar padding. So it's defaulting it on like multiple levels. So it's specifying it 3 times. I kind of want to go for like simple code. So like remove the defaults on the bar padding. Assume that it is passed in at the top level of the viz function. Just to sort of simplify and clean up the code. That's strange how it's taken a long time. Maybe it crashed or something. I'm going to refresh. Let's try that again. There it goes. Yeah, so I just like the minimal cognitive overhead because just based on my experiences navigating code bases that have defaults, it's like if you're in the innermost part, or like you come at the problem and you want to change it, you don't know where the definition is coming from. You have to do a lot of work to like track, is it like, okay, it's defaulted there, but in the parent level, does it have a default or is it passed in? So this just makes it a lot easier to find the one true source. Okay, cool. But anyway, we were just reviewing create scales. Now bar padding is an option, not hard-coded. And then this Y scale thing is a very important idea. So instead of going from the min to the max, it goes from 0 to the max. And in my opinion, this is critically important. It's called a zero baseline. And if you don't use a zero baseline with bar charts, the bar charts can be misleading because the way you interpret a bar chart is you look at the length of the bar and assume that that length of the bar actually corresponds to the value. And so if the value itself were 0, like population of 0, you shouldn't show any bar, right? But let me just show you what it would look like if we say min data, comma, y value. It crashed for some reason. What happened? Oh, min is not defined. Right. Sure. I need to import that from D3. Oh, well, it depends on the rendering logic too. But see how just imagine those bars started at the bottom. See how it would be misleading? So anyway, I'm going to put it back to 0 and just say it's important to have a 0 baseline with bar charts. But that's it. Like, that's the essence of a bar chart as a visualization idiom. Coming back to Tamara Munzner's textbook and the mental model there. So just to summarize how this fits into there, the bar chart is visualizing, in this case a vertical bar chart, is visualizing one categorical or ordered attribute of the data as x, and then a quantitative attribute of the data as y. And to do that, like translate that into D3, we use a scale band for x and a scale linear for y. And as a little aside, log scales work for scatter plots and other things, but they don't really work for bar charts. Again, because the way our perception system, visual perception system perceives the bars, I think it just makes sense to correlate the area of the bar exactly with the value, proportionally. So anyway, that's how you set up the scales for a bar chart. now let's take a look at the render bars function. This is the one that actually renders the rectangles. So let's see what's going on here. This is AI generated, so I'm proofreading it as we go. So notice that we have rect elements instead of circle elements, and we have x and y instead of cx and cy. And the x position of an SVG rectangle specifies the left side of it. And so the scale band, when you pass in a value from the domain, the value from the range is actually the leftmost pixel coordinate of the bar. And then you need to use another thing from that same scale called bandwidth, and that gives you the value to use for the width of the bars. And then height, I'm a little confused, honestly, about this. Why is it math.abs? I don't think we need that. Yeah. I don't know why that was there. Some edge case, maybe. But we don't have that here, so this makes the most sense to just subtract y scale of 0 with y scale of y value of d. And the reason why that makes sense is because the y, just gotta keep in mind, the y value of the rectangle is the top of it. And then the height is like extending down from that top to the bottom, which is y scale of 0. So y scale of 0 gives us the pixel coordinate of the bottom of the bar chart. And then we subtract from that y scale of y value of d, which is the same thing we're using for the y coordinate. So we're just subtracting the bottom from the top, and that gives us our height. And then we have all the same selection logic and interaction affordances from before, the cursor and the clicking. So that's it. That's how you make a bar chart with Reaction D3. Let me just tweak the margin before I set this down. So the margin should be in app.jsx, I think, right here. It's one of our tweakables. We'll just alt drag on left to move that around. And same thing with the bottom. Just bring that down a little. And then the label for the x-axis, you can move that around a little bit too. Okay, that looks decent. And there's so many things we could do from here, but this is the basic core essence of a bar chart. Any questions? And we never really stopped and looked at the data, what this is really showing us. Let me open up this full screen. And by the way, oh, I love this. I'm changing the browser zoom here. Because we built this on an earlier thing that was responsive, that has the resize observer, we can do things like this, like just change the resolution. And it measures the updated width and height and like optimizes it for our view. Like, this is amazing. So if you're like old or something, you can't see it, you could just like crank up the zoom and it's much more legible. Totally legible. There you go. I moved my little bubble. The reason I chose this data set to work with is because I want to use this course as an opportunity to understand the world in terms of data. And when you think about what is the world, in my mind, it breaks down between time and space. Space being like geographic coordinates on the planet Earth, which is subdivided into these artificial boundaries by humans. They're called countries, right? And so I'm like, oh, well, to understand the world and all the people in it, we can start looking first at the countries. Which countries have the most people? And I think this is old data. It's not up to date. Maybe it's 2010 from the United Nations. You could plug in fresh data. That would be a good exercise for the reader, or extend it to more countries. Or look at something else like languages, religions. But anyway, if we look at this data visualization, we can see that China and India have a huge number of people. Those are the largest two countries by population. And then coming in at third is the United States. And then there's sort of a long tail after that. But China and India are on a whole other level. And this fact is really clear when you look at the bars and your eyes see the difference in size between the bars. And so then it's the United States, Indonesia, Brazil, Pakistan, Nigeria, Bangladesh, Russia, Mexico. And it would be interesting to see how this changes over time. Like that would be another great thing that we could do in another session. The animated bar chart, or the so-called bar chart race, where we look at data going back in time and have like a year indicator where I am right here saying like 1990, 1991, 1992, and then the bars would shift around. That's something we could do. And then that data could be visualized as a bump chart if you want to see the change in ranking over time. But these are just some of the visualization design ideas that come out of looking at a bar chart, thinking about a bar chart. One aspect of people I find very interesting is religion. There are various religions, and I think you can call it adherents, people who adhere to or follow different religions. What I'd like to do next from here today is to fork this and modify it so that each country has a breakdown by religion. And so that would be a stacked bar chart. So I think that's what I'll do next. I'm feeling it. What do y'all think? I'm going to go for it. So, I did a version of this in the past that I'll pull in the data from. And this is also from an earlier version of this course. Oh, where did it go? There it is. So yeah, this is the version I built in the past, and this is actually what I would like to drive towards in this course too. And again, this is just using older D3 patterns, but I think we should be able to pull a lot of Actually, this is a nice pattern. I think we can pull a lot of logic out of here because the stacking and the grouping is always something super, super tricky. Like I could never quite wrap my head around it, so I would just like tweak it until it worked, kind of thing. And it's like just like that with AI now. Like make it stacked. And like usually you don't have to understand it to a very deep level, but I would like to do that actually once we get it working, just so all this code becomes clear at the end. But anyway, I'll start by forking this viz and call it CV stacked bar chart. And initially, what I'm envisioning is we pull in the religion data and then just have this exact visual form, a vertical bar chart, but each bar will be subdivided by religion within each of these countries. So we'll be able to see a breakdown of religion per country. To make that happen, I'll first pull in the data from this. Here it is, religion by country, top 20. I'll just go to data.csv and drop that in here. And then I'm just going to try the AI prompt and see how good this is. Please change this around so that it is a stacked bar chart that shows country on the x-axis, but uses the new data to break down each bar by religion using different colors. Do not add a color legend yet. Let's try that. And there it is. It worked. Now, I think the first thing I see is that these population numbers are off. It could just be a unit issue. This is a manual, probably a manual thing. Or you know what? Once you have code, we're searching around for any scaling logic. Yeah, let's pull this into. So if you see, oh, DR Congo is there. It did some name replacement on us. I think I'll just do this manually. Or hell, why not? Let's just use AI. Scale down the population values like this. And I just dropped that snippet. Okay, population millions. Just as a sanity check, does this match the numbers on the other ones? Well, actually, you know what? I kind of like the millions unit. but that other one's already sort of baked. So let me keep it as, I just restored to the old version. Let me keep it as population thousands, but there's clearly something wrong with these numbers. So at 1,400,000,000. We should get these numbers right, make sure they're right. What was the population of China in 2010? So 1.37 billion. So this is actually kind of hard to read. But let me just make this one match. Maybe I'll circle back later and do a refinement pass on both of these. I'll just do this manually. The app that loads the data, we need to divide population by something, maybe 1,000. So now for China, it's around 1.3 million thousands. And that basically matches what we had for the other one. Okay, great. So it's now basically truthful. So let's take a look through this code and see how the stacking works. And the colors too. This is the first time we're using colors. Starting in app.js, the data parsing is now updated to pull out religion and also parse the population differently. And then it's doing something group data by country and aggregate religions. This seems overly complex because D3 has some utilities to do this. And this also. And this is another sort of foot gun with AI. It's like sometimes it does things in kind of a complicated way. And it's not that complicated, but this could be like 2 or 3 lines of the D3 utilities. Let me just say use D3 stack utilities. Use D3 data utilities for this part. What did it do? No, it just moved it to another file. Let me say try harder. There we go. Roll up. D3 roll up. Thank you. That's good. And it's actually nice to split that out into a different module anyway. So we call process data on the loaded data, and we pass that into set data. Nice. And we could just simplify that a little bit. And then process data, maybe it's just inevitable that we need some degree of complexity, but this is using D3 at least. So there's this utility in D3 called rollup. They're super awesome. So D3 group and rollup deal with various types of aggregations. And this is where the documentation is really nice to just look through as a reference. So rollup is the thing that groups and reduces things. Which we need to do for our case. But this, I don't know, this is not really making sense. Let me just say with AI, simplify the data processing as much as possible. No, this is no good. It broke. Anyway, let's just do a pass of studying this code to see what is actually going on. So we're calling process data. It's parsing the things out. It's grouping them together, and then sort of calculating total populations as well for each group. So it may be useful to look at just to understand loaded data versus final data. So let me console.log. Whoa, I think while I was typing that previous AI request finished and did the update. Okay, I need to work on the user experience around that. So like if a generation is happening, it should tell you that. All right, so rewind a little bit. Let's just study what that latest AI generation actually did. So we have app.js, and then we're calling process data. And this is simpler too. We're just assigning population. We're not touching the other ones because they are already strings. So we're just parsing the population out. And then in process data, we're calling group. Okay, we're calling D3 group and doing grouped by country. This is great. So now let's study what is D3 group actually doing. We can say console log loaded data versus grouped by country. So loaded data, just to review, it's an array of objects, each having a country, population, and religion. So this population is the number of people for that specific cross-section, that specific combination of country and religion. But let's see what the output of this call to D3 group is, where we just pass in the loaded data and then an accessor function that pulls out the country. So what this does is it creates a map, or more specifically an intern map, but that's a detail. Consider it a map, meaning a JavaScript map, a lookup table between keys and values. And then the keys in this map are the countries, and the values are the rows from the original array that match that specific country only. So this is just isolating those arrays. So like if we drill into Vietnam, these are just the rows that match Vietnam. So this is like all the counts within just one country. So that's what D3 group does. Super nice data processing utility. And then we're creating the final data structure, including the stack layout. I'm a little confused though, because why not use D3 stack? Use the D3 stack utility. Oh, it doesn't run anymore. Try harder. Yeah, this feels better. Because it's like the stacking, yeah, you could do it in vanilla JavaScript, but there's a utility for that. So let's use it. So this is the updated version. Group is still there. Great. And then what we're doing is transforming the data into the right shape that the D3 stack utility expects. Namely, each object represents a country. And there are properties for each religion. So it's like a kind of a weird pivot, kind of an operation on the data. So let's do another before and after comparison. Like let's do console log stack data compared to grouped by country, just to see what this is doing. So grouped by country is the map that we looked at earlier, and then stack data has each row as a country, and then various properties of that row being the values for the different religions. And this kind of data transformation is often the trickiest to get right when you're dealing with stacked bar charts, grouped bar charts, or stacked area charts. It's the same kind of a thing that you need to do. But anyway, this is all pre-processing to pass it into d3.stack. So here it creates an instance of the D3 stack layout. Again, that's well documented on the D3 documentation site. And then we pass in a thing called keys. And keys is all religions. And where was that defined? It's just isolating all the religions. And I believe this is where we could sort them if we wanted to. Like sort them alphabetically. because right now it's kind of random, I think. But anyway, it's calling array.from. So yeah, just if in case you haven't seen this kind of code before, it's making a new set data structure which deduplicates things within it. So if the same religion gets added twice to the same set, it gets collapsed into just one entry. And then that's the set data structure documented on MDN, JavaScript sets. And then we're using array.from to convert that set into an array of strings, which is all religions. And then I kind of want to put .sort just to like alphabetize them, because why not? And then we have our stack layout, and we just pass stack data into stack layout. And now let's see what does that do. Console log stacked series, the output from stack layout. Now this is a whole other thing. It's an array of arrays, and each inner array is where that specific sub segment of the stacked bar should begin and end in terms of the data space, I believe. So notice how all these first ones start at 0, go to some value, but then the second one in, it uses the previous value as the first value. So it's the stacking of the actual data values. And then it's one of these weird data structures where it's an array, but then there's a property on the array called data. You'll see this all over D3. But this is the original row from the pre-processed data that feeds into this particular stack. And so this is what we will translate into rectangles. Each one of these gets a rectangle. And I just want to point out, see how this, for China, the first part of the stack goes from 0 to this number, 2, 4, 4, 1, 3. And then the second part of that starts there. See how it's the same number, 2, 4, 4, 1, 3, 0, 0, 0, 0. And so that's the stacking idea. And then after we did that, it's getting transformed again. And this is where it's computing the total population. Yeah, I'm not really getting the point of this. It could be AI slop. But let me just keep this here for now and study the downstream code. So in app.js, after we call that process data, so that does actually a lot of the transformation that is associated with the stacked bar chart that I would actually expect to go into Viz. So we can move it later. But here we go. We're creating unique religions for the color scale domain. Okay, this is where I would want to see a color value accessor. So for AI, create a color value accessor alongside X value, Y value, configured outside viz.js. Yeah, this just cleans things up a little. And it also, in a nice way, moves the definition of the color scale outside of viz, which could be potentially useful if you want like a color legend based on the regular DOM. But yeah, from here on out, it's more like refining the code to my personal preferences and making it like super crisp and clean. So yeah, let's move this into viz, which I'll do manually because that's the only place it's used. Because I could imagine putting a color legend in here. It would be like render color legend kind of thing. Oh, create color scale is not defined. Yeah, need to import that. This is where I missed the VS Code thing. That would be a cool thing to build into VizHub, the auto import. Yeah. I'll just grab that out of app.jsx and drop it into viz. All religions. Yeah, now this is where that should be derived based on the color value. So I'm going to move that into viz.js. And then do a refactoring. So like remove all religions from viz.js and instead compute something more generic based on color value. Yeah, I like that. More, it's just more generic and it uses the color value. But this is kind of silly. We can just do it like this. Okay, this is interesting. Data.flatmap. So this is just a way of pulling out from that nested array structure. Although, you know what? Oh, I'm sorry this is taking so long. But I want to do this in a clean way. So I don't like the idea that the data here is the processed data. So I just want to call process data from within viz.js, not in app.jsx. That gives us a higher degree of sanity around the type here of data. Like I think data that you pass into the viz function across all these different examples should just be the loaded data without any processing. So let me say move the call to process data into viz.js and out of app.jsx. And then like rework the color domain to use the unprocessed data because that's simpler. Okay, it still runs. Let me see how that looks. So I'll just look through this diff. There's no longer process data. Perfect. Just setting data to be loaded data. And y value is population. I like that. Yeah, simpler. And then we're calling processed data, but we're still passing processed data into create scales. But I think that could be like a necessary evil because the scales do need to know about the stacking. So I want to circle back to understand what create scales does. But this is the thing that inspired this edit, is because I'm like, data.flat map? No, we don't need that. We just need a regular data.map. We could just pass color value in there. So simplify this. To just this. Yeah, that's good. It's much simpler. So array.from new set data.map color. That's right. That's exactly right. That's how we figure out the color domain. Okay, cool. So where were we? In viz. So now we're calling process data here, and we're saying create scales with processed data. And so just to avoid confusion, I'm going to rename data to be processed data. So we know in create scales that we're dealing with processed data and not the original data. And so let me just add here, like, process data is the output from the stacking. So yeah, it's just passing x value as an accessor, mapping over the processed data. Let me just refresh my memory on what processed data actually returns. This is where, like, there are a number of different alternative solutions to this problem of computing the totals. So what this does is it computes the totals because that's what we need for the scales. And then it's assigning religion, population. Just for understanding's sake, let me just console.log final data. So final data is an array of objects, each of which has total population. And then within that, there's religion, which returns population. So my question is total population even used? So the x value that we pass into create scales is this. It's total population. Oh man. I don't really like this. I don't really like this. Um, because we're duplicating, like, we have this custom logic for total population. Can we avoid this and this? So the whole computation of final data, like I would really love to just pass stacked series as the return value. So in my prompt, I'm saying, can we avoid this and just return stack series from process data? Okay, it still runs, so let's see what changes were made here. Yes, we can, to avoid the manual stacking transformation. Thank you. However, it requires updating other parts of the code. Yep, we need to adapt everything to use that structure, which I think makes more sense. It's easier to understand because you know it's the output from D3 stack. So, and then we will compute the max from the stacked data. That's the key. That's what the key. Uh, that's what I like to see. So let's see, what did it do? It removed that whole manual computation of the totals. And then we're extracting country names. But again, hmm. But we're not using y value, which is frustrating. Because all this stuff should just use a y value automatically. So let me just say change. See, this is where I'm getting ahead of myself. Let me review this whole diff first. But I can aggregate. This is another way I love working with AI, just to aggregate the changes. Please make the following changes. Change this to use y value. E.g., I would love to see actually, you know what? It's duplicated. I don't like this whole solution. Let me say try harder. Use better AI. The second time today I'm seeing performance problems here with this. last time this happened. It did eventually finish the edit. I'll just give it a little more time. Oh, there it goes. What? Okay, that was Claude 4.5 Sonnet. Maybe I like accidentally enabled thinking mode or something. I don't know. It took a long time up front. I gotta check on that. But this looks pretty good. So the main thing is this was duplicated and I don't want to see duplication there. So all religions should be done just once and then passed and used different places. I hope it does that. Oh, it's appending an ID. Oh, wow. So it implemented the interaction of selecting. See, that's kind of baggage from the previous example. And thinking through it, I wonder if we'd want to actually select an individual part within there. But that adds some complexity because we need to assign IDs. Okay, so what are we doing? We are creating the stack layout and then returning stack layout of stack data. Great. In viz.js, we have stack series and then countries. Oh, right, yeah, countries. We have to do this for countries. So it's stack series, it's just a guard to see if the data's messed up. And then we're taking the first element of the stacked series, so the first country, or sorry, the first religion. I don't know. But we're just mapping over data data country. But again, we're not using the accessor. Use the X accessor for this part instead of hard coding country. That's one piece of feedback. And then this is what I like to see, the Ymax. And so with a stacked bar chart, I would say one of the trickiest things to figure out and understand is how do you know the total for each of the groups? Because we need to use that for the scales. So we're computing Ymax here as we have this guard. You know, as another piece of feedback, we don't need this guard. We know the data's good. But the main thing here is this little expression where we take max from D3, so that takes as input an array and figures out the max. And then we take the last of the stacked series. And this is the religion that appears on the very top of each of these stacks. So it's like after, so we are taking advantage of the fact that the D3 stack layout has already computed the total for each country. It's just encoded in the stack layout as the second element in the array for the last part of the stack series. And so what we're doing is we're taking the max of those over all countries. So stacked series at stacked series.length minus 1 is the last religion in the stack. And then we're just looking at the first element, or the second element, the max element of those arrays. So this is correct. And it's generic, so we're not duplicating any of the accessor logic. But yeah, it's super tricky to wrap your head around this. If you want to really understand this, go in and just console.log each thing until it like clicks. And then we're passing countries into create scales, which I don't really like, but it's whatever. I can circle back and fix it. Yeah, I much prefer. So this is another piece of feedback. It's almost like working with a freelancer where you give a batch of feedback for a revision, right? So do not pass countries into grade scales. We want the code to be data agnostic. Please use something more generic, like, I don't know, X values. X values are X domain. And then in create scales. Yeah, like I kind of like what it was before. And render bars is getting more generic, which is good. So instead of country group, it's series group. Instead of country, it's d.key. And yeah, this is kind of a lot to take in, but the differences are nice. So previously it used the y0 and y1 from the manually curated stacking, but now it's just leveraging the output from D3 stack, which is good. Okay, so this might be the final revision to clean things up. Execute all that feedback. That didn't work. Try harder. Yeah, I gotta fix this issue with VizHub. Why does this part take too long? Maybe it really is formulating a plan. Maybe it's the thinking aspect. Okay, that worked. Let's see, what did it do? It computed X domain. Very nice. Very nice. It just deduplicated the X values. hard to see what's going on here. But when it passes into create scales, it's now passing X domain rather than countries, which is good. A little more data agnostic. Yeah. Okay, looks great. This is probably just a reformatting. Oh, it removed the guard. That's what's going on here. It removed this guard. So it's much simpler now. Let me actually look at viz.js. And see how it's simplified things. So this is it. The Y max is much simpler now. Now that we don't have that guard. Okay, that's it. That's how you create a stacked bar chart with React and D3. Now that was a little bit of a rocky road, but hey, sometimes that's what it is with the AI code editing. Let me do one final review of all that because I know it's a lot and it can be complicated. So app.jsx just loads the data, doesn't do any processing, and it passes the data into viz along with color value, which is a new accessor for our color. And then in viz.js, we call out to this other function called process data. And process data does some heady, weird stuff with D3 stacking and grouping. But it ultimately returns stack layout of stack data. And this is what we need to understand the structure of. So let me just console log that and let's take a look at that. It's an array of arrays, and each inner array has the stacked values. So at index 0, it's the bottom of that stacked layer. At index 1, it's the top. And then nested within that is the original data row from the pivoted data that we may need to access. And so each inner array here represents a country and has one property for each of the religions. So that's process data. Moving along in viz.js, we compute the X domain by deduplicating all the X values from the data. And then we compute the Y max, which is the max last stack entry over all the bars. And we get that by taking the highest stacked religion. And then for each of those, we access the first element of that array, which is the max, the top value for that particular stack. And we aggregate the max over all those to figure out the max of the Y that we will feed into the Y scale. So then we call create scales, and what create scales does is it does the scale band, same exact like before, but now we have X domain. And I wonder, is X domain used anywhere else? Because it's kind of weird that we compute that out here. Let me just do a little change. So I think that's the only place that it's actually used. So instead of defining it out here, we define that inside of create scales. And for that, we need to pass in X value. This feels better. So I'll pass in X value to create scales, and then also the data we need. So data and X value. I should add the data from the outer side, and then it should light up again. Okay, great. Yeah, and then, if this is the only place we're using it, this kind of deduplication actually happens. Whoa, there was a clap sound effect. That was crazy. This can be simplified even further because this kind of deduplication of the unique values is done automatically inside of the .domain function of scale bands. And so we can just pass data.map x value here and simplify this whole thing down, and it works just the same. Great, and then our y scale comes from this y max, which we had to compute using the stacked layout. But this is good because the create scales function doesn't need to know the fact that it's stacked. We just need to give it the y max. So yeah, those are the scales. And then we compute the color domain. Now, tell me, why do we have a create color scale? Like, why don't we just do this inside create scales? Let me say, move this logic inside the create scales function. Yeah, this makes sense because it is a scale, right? Let's group it together with the other scales. So now we're just calling create scales, and it's creating all three scales. And then inside of here, we have a couple more options, the color value. And the beautiful thing about options objects is you can drag these around. I like to put the accessors next to each other in the list. And again, okay, so we have create color scale. So I kind of want to fold this into create scales. I hope the AI understands that idea of fold. Yeah, it did. So this is cleaner, I think. It's all in one spot. And then maybe the AI doesn't get this, but all we need is data.map, because for scale ordinal, again, the deduplication happens inside of the .domain setter. So we can simplify it further. And then these are the colors. This is a tweakable, right? So let's pass in, actually this is color scale range to be more specific. So let's move the definition of color scale range to another option on the viz function. So now it still works, but then the definition is moved out to the section of tweakables. So now if you wanted to change the color or the padding or the label offsets, all that is in just one spot. And speaking of things we need to tweak, the margin needs tweaking. let me just go in and say the left margin needs to change. Okay, now we can see that label. Very good, very good. So where were we? Create scale. So now, yeah, we have this color scale range, and I like to group that with color value. Yeah, so anyway, it's sort of cleaned up. So create our scales, and then we say render bars and render axes. And when we do render bars, we pass in stacked series as data, but just to avoid confusion, I'm going to rename data to stacked series inside of render bars. Because if it's data and it means, like, I just want to avoid the case where data means different things in different places, which could be super confusing. So now it's clear. This is the output from D3 stack. Yeah, this one. So we create a group for each religion series, an SVG group element, and then we set the fill on that group element. So yeah, this is a kind of a crazy aspect of how D3 stacked bar charts work. I want to show you how this is actually like decomposed. So each series group contains all the rectangles that share the same color. And I think it was done this way so that you can set the fill on the group, and you don't even need to set the fill on each individual rectangle. It's kind of nice. So see, in this series group, the fill from that group element cascades down into the children. So I'm hovering over all of the blue rectangles. So that's what that series group is. So we're creating one group per stack series using the key as the ID function for the data join. And then the fill, we are passing that into the color scale because d.key on the stacked data is derived from the color value return values in the upstream code. So that's why this works. And then this is something I don't think we've seen before, a nested selection. So when you create the data join, you pass a function as the first argument instead of the data array. So normally when you say .data, you pass in the array. But if the first argument is a function, and you call that on an existing data join, that creates a nested selection. Just a lot to wrap your head around. Ooh, point.data.country. No thanks. That should use the accessor. So that it uses, I believe it should be x value of point.data. Because these inner functions should have no clue about the data set. Should be reusable across data sets. This is not right. What is this? xscale.domain.index of? Try harder.
Can I ask a question while we're waiting?
Yeah.
Uh, this is going back to we were talking about the process data function to grab stack data.
Hmm.
Could you use that to organize collapsing sunburst chart or like a donut chart that collapses?
So you're asking, would we have a similar function to process data for a sunburst chart that is collapsible?
Yeah.
So firstly, to develop the static version of a sunburst chart, there could be something similar to that. Yeah, like if the data processing logic ends up more code, I would just want to split it out from the main app.jsx or whatever to a separate function, but it has nothing at all to do with the interactions. Because the collapsibility, I would want to track that as a piece of state in React.
Uh,
And the examples you see out in the wild of collapsible sunburst, I don't believe do that. Um, like probably in observable, you would find something that does it like in a very imperative way where it mutates some field of the data, like is collapsed or whatever. But I think I would want to do it in a different way to just decouple the data processing that happens once when you load the static view and then the expanding and collapsing. But if you have a case where the data processing depends on the state of what is expanded and collapsed, then you may need to rerun that data processing every time the state changes. Is that kind of what you were getting at?
yeah, sort of, because there's we're just looking at the way it was stacking the data in this one because building out a sunburst, you have like this nested collapsible sunburst. You have like a bunch of nested data that I'm just not sure how to build in a
Yeah.
JSON format aside from manually. Like running it.
Mm. Yeah, let's do that. Actually, later in the series, I will be doing tree visualizations. Sunburst is one of those. And so it's a whole other um, area of D3. But it's kind of similar to the stacking in that you call some kind of a magical function from D3 and it computes this thing called a hierarchy. And you can compute the hierarchy in a number of different ways. One is, like you said, manually craft the JSON with the children array and the nested stuff. But there's another way to derive trees from CSVs in D3 called stratify. And so if you have a table like a CSV of parent-child IDs, it can transform that to be the hierarchical data structure that you need for the sunburst. But yeah, we're getting sort of ahead of ourselves. Thanks for the question. That's great. That's great. I love questions. Yeah, I hope like as I keep doing this week after week, it'll gather more momentum, more people will come and ask questions. And also steer the future episodes. Like if you have some ideas, like that's a great idea. Like maybe I'll plan to do a sunburst next time, or some other tree, or at least start on the hierarchy stuff.
Cool. Yeah.
Because it all kind of comes as a package deal. The trees, because like once you compute the hierarchy, you can use a number of different visualizations. But anyway, circling back to this. Okay, that finished. This is more like what I like to see. So now render bars takes as input x value, and it doesn't know about the fact that the data set has countries. This makes it generic. So you can just change the accessors and everything will kind of flow later. Yeah, that was a pretty nice change. So that's pretty much it. This is the last frontier to like understand deeply with this example. There's a nested selection, and the ID is the x value. It's kind of hard even for me to parse this, but the x value is x scale of x value data data. Makes sense. The y value pulls out the top of the bar, which is d at index 1, and this is the data structure output from the stack layout. And then the height needs to reference both the top and the bottom of the stack. And let me just pull out these comments so they're above the lines. But yeah, this pretty much makes sense. And then everything else is cool. It's like inherited. We have this click interaction where you select the whole stack, which we could revisit, but I think I'll just keep it like this just to maintain some idea of interaction here. But the next logical step would be to build out a color legend for this, which I think I'll leave for another time. I just want to tweak this margin. I feel like I already tweaked this margin, but it somehow got reset maybe. Yeah. But actually, with AI, it might be possible to get the color legend in like 5 minutes, especially because there's a previous implementation. Yeah, let me just pull this in and say, go to the files, copy for AI, and say to this AI, add a color legend with interaction based on the following reference example, but using idiomatic React. And then I'll just paste all of that. But I'll remove the formatting instruction. So that copy for AI, we don't need the README, but it just copies in all the implementation from that other example. Let's see if it can do it. Oh, wow. Look at that. Whoa, it works. This is incredible. Oh my gosh. Well, this is a lot to unpack too. But it's doing some weird stuff. Import React from React. I feel like I'll have to do a lot of cleanup work. This is the less powerful AI. I'm just reading through here. Like that's not right. No. Let me try again with the more powerful model. This is Claude now. Oh, but it's using React for the DOM manipulation. Oh, it misinterpreted what I said about use idiomatic React. No, I like the idea of keeping it in SVG. You know what? Let me do that another time. Let's keep it at this for now. That's a lot for today. But maybe next time I'll add the color legend and maybe do a scatter plot with color, or maybe a line chart with multiple lines to flesh things out with color.
What about a four quadrant scatter plot?
Yeah, four quadrant scatter plot. What do you mean? Like the
Like there's a plus x, a plus y, and then a minus y plus x, and then a minus y minus x, and then a the whatever the fourth one.
yeah, totally. I know there's a lot of like conceptual frameworks with quadrants, and then you can position the points in the quadrants, like the Gartner Magic Quadrant, maybe. That's something I've heard about. But yeah, let me know if you have some ideas. We can maybe chat in the Discord about like ideas, data sets. I'm always on the lookout for cool data sets to pull in too. So if you know of something that would translate well into a scatter plot with quadrants, which is yeah, another visualization technique, that would be cool.
Cool. Thank you.
Oh, there's that clap. It's a Discord thing. I was so confused earlier. I'm like, what was that? Anyway, thank you so much for joining, and thanks everyone who's watching on YouTube. We got 4 viewers. That's something. And yeah, looking forward to continuing the series next Friday. Okay, take care, everyone. Bye.